In question 171, it is asked, malonate is a competitive inhibitor of. You know that competitive inhibitor, they compete with substrate for binding with active site of enzyme, and malonate, it competes with succinic acid to bind with active site of enzyme succinic dehydrogenase. So, malonate is a competitive inhibitor of succinic dehydrogenase, making option 2 as the answer for our question. Talking about the rest of the option first, that is malic dehydrogenase. This cannot be an answer because malonate is a substrate for malic dehydrogenase which catalyzes the conversion of malonate into oxaloacetate. So, this cannot be an answer. Option 3, that is carbonic anhydrase. And you all know that carbonic anhydrase, it catalyzes the formation of carbonic acid, and this enzyme plays an important role in transport of carbon dioxide from tissue towards lungs. So, this cannot be an answer. Option 4, that is cytochrome oxidase. Cytochrome oxidase is an important enzyme of respiratory electron transport chain, and cyanide is a non-competitive inhibitor of cytochrome oxidase. Cyanide is a non-competitive inhibitor of cytochrome oxidase. So, this cannot be an answer. Question 172. Living system represent. You all know that living state is a non-equilibrium steady state to be able to perform work. What is the meaning of is a living state is a non-equilibrium state? Non-equilibrium क्यों? Because at equilibrium no work can be done. So living organisms, they work continuously to prevent falling to the equilibrium. So living state is a non-equilibrium state. And the second part which is given, it is a steady state, means various concentration of the biomolecules, they are maintained at a proper level in our body. So that's why living state is a non-equilibrium steady state. So in the question it is given, living system represent option first, equilibrium non-steady state. This cannot be an answer because living system represent non-equilibrium steady state. Option 2, that is non-equilibrium steady state. This is correct regarding living system. Option 3, that is non-equilibrium non-steady state. Living system is a non-equilibrium steady state, not non-steady state. So this cannot be an answer. Option 4, that is equilibrium steady state. This cannot be an answer. So the correct answer for this question is living system represent non-equilibrium steady state, making option 2 as the answer for our question. Question 173. Streptokinase is used as A or N. You all know that streptokinase is a thrombolytic medication. Thrombolytic medication. It is used to break blood clots. In blood vessels which are formed during heart attack, pulmonary embolism, stroke, etc. So let's see our various option. Option first, that is prosthetic group for many enzyme. This cannot be an answer. Option 2, that is natural anticoagulant in hemodialysis. Natural anticoagulant which is used in hemodialysis is heparin, not streptokinase. So this cannot be our answer. Option 3, that is clearing agent of blood clots in blood vessel. This is true regarding streptokinase. And option 4, that is artificial anticoagulant in hemodialysis. One of the artificial anticoagulant which is used in hemodialysis, it's citrate, not streptokinase. So this cannot be an answer. So the correct answer for this question is streptokinase is used as a clearing agent of blood clot in blood vessel. That is option 3. So let's proceed to our next question. Question 174. Select the correct statement. Option first, in feedback inhibition, inhibitor bind with active site of an enzyme. This statement is incorrect because in feedback inhibition, the inhibitor bind with allosteric site, which is completely different from active site of an enzyme. Allosteric site, not with active site of enzyme. So statement first is incorrect. Statement 2. Coenzyme is an inorganic compound tightly bound to apoenzyme. This statement is also incorrect because coenzyme is an organic compound and their association with apoenzyme is for short period, usually during the catalysis of reaction. So this cannot be our answer. Option 3. Cyanide kills an animal by inhibiting carbonic anhydrase. This is also incorrect because cyanide kills an animal by inhibiting cytochrome oxidase. Cyanide is a non-competitive inhibitor of enzyme cytochrome oxidase, which is an important enzyme of respiratory electron transport chain. So statement 3 is incorrect. Statement 4. Competitive inhibitors are frequently used in control of bacterial pathogens. This statement is correct. You know that folic acid is essential for all cells, and so bacterial cells, they also require folic acid. Folic acid cannot cross bacterial cell wall by diffusion or active transfer. So bacteria, they have to synthesize their own folic acid molecule. Bacteria, they synthesize folic acid by para-amino benzoic acid is used by bacteria to synthesize folic acid. And most of the drugs which are used to control these bacterial pathogen, they usually act on the enzyme which is involved in this conversion of para-amino benzoic acid with folic acid. Usually most of the sulfa drugs which are used to control bacterial pathogen, they are competitive inhibitors of the enzymes, and they compete with para-amino benzoic acid for binding with the active site of the enzyme. As a result, bacteria will not be able to form folic acid and their growth is controlled. So statement 4 is correct here and is also the answer for our question. Question 175. Select the type of enzyme involved in the following reaction. So in the given reaction, there are two substrate, S, G and S dash, and this reaction leads to the formation of product S and S dash G. So we observe that group G has been shifted from S to S dash during the formation of product. So there is a transfer of group, and such reaction are catalyzed by enzyme transferases, making option 4 as the answer for our question. Talking about the rest of the option 4, that is ligases. Ligases catalyze the formation of covalent bond between two molecules. So this cannot be an answer. Option 2, that is oxidoreductases. Oxidoreductases, they are involved in catalyzing oxidation reduction reaction. So this cannot be an answer. Option 3, hydrolases. Hydrolases, they catalyze the breaking of the bond by using water molecule. So they cause this hydrolysis. So this cannot be an answer.